Welcome to Generative AI Futures, brought to Bite Goose AI. Today, we're really doing a fundamental demolition job on what we thought we knew about healthcare AI. We are going to dig deep into the technical launch and the architectural blueprint of ChatGPT Health.
Which just came out, what, January 7th?
Exactly. And you might think, oh, it's just the general model with a medical prompt. But our sources show this is a specialized, ground-up rebuild.
That's the critical insight.
Yeah.
And that's really our mission today. We need to uncover how they engineered that connection between the brain, the general LLM intelligence, and your actual fragmented, sensitive clinical history.
Because that gap has always been the single biggest failure point.
Always. The disconnect between general knowledge and specific personal data.
So we're not just looking at a better algorithm. The source material is adamant this isn't a single model. It's a unified system.
A huge architectural pivot. It
Yeah.
uses the new GPT-5 family, sure, but it's the safety protocols, the data prep, the new reasoning constraints. That's what makes it different.
All right, let's start with the engine room. The GPT-5 ecosystem. It sounds less like one big model and more like an orchestra with a very sophisticated conductor.
That's a perfect analogy. The conductor is what they call the metacognitive layer. It acts as a real-time router.
So it's triaging questions on the fly.
Instantly.
Yeah.
It classifies the complexity and the risk of every single thing you ask. So if you ask something simple, like, what's the recommended vitamin D dosage?
Okay, low risk, informational.
Right, that's low latency routing. It gets sent to a standard, fast GPT-5. The priority there is speed.
But the second I bring my personal data into it, like, hey, considering my recent kidney panel and my blood pressure meds, can I take more potassium?
That's the trigger. That immediately gets flagged for high reasoning routing. The query is sent straight to GPT-5 thinking.
And this is where the tech gets really interesting. GPT-5 thinking uses something called test time compute.
Yes.
Let's unpack that. Test time compute sounds pretty abstract. What does it actually mean for the quality of the answer I get?
Think of it like a digital self-check or a draft mode that the model runs internally before it ever gives you the answer.
So it's not just spitting out the first thing that comes to its circuits.
Exactly. A standard model just generates tokens one after another. GPT-5 thinking allocates extra compute power during generation to build out and then verify its own logic chains against your clinical data.
It's asking itself, wait, does this claim I'm about to make contradict that lab result from 2 years ago?
Precisely. It writes a draft, it proofreads its own reasoning, and it edits for consistency. And the metrics on this are, well, they're powerful.
What are we talking about?
We're talking about a 65% reduction in false claims
65.
and a 45% drop in hallucinations compared to GPT-4o.
Oh, yeah.
In healthcare, that is the difference between a useful tool and a dangerous liability.
That grounding is everything. Which leads us to the training itself, safe completions. This sounds like a re-engineering of the model's core values.
It is. It's a huge departure from standard RLHF. See, if a user tries to game the system by asking for a diagnosis for severe symptoms.
The old models would kind of try to follow along because they're trained to follow instructions.
They struggle, yeah. Safe Completions explicitly trains this model to prioritize a predefined clinical safety boundary over just following the user's prompt. It knows where the line is.
So it recognizes the risk signal in the prompt itself.
If a user starts describing an acute mental health crisis, the model is trained to see that as an emergency. It doesn't engage in a long, drawn-out conversation. It pivots.
And what does that pivot look like?
The result is a documented 25% reduction in what they call non-ideal model responses in these situations. It just immediately shifts to providing resources, hotlines, referrals. It's a systemic emergency override.
Okay, so we've established the brain is smart and it's safety aligned. Now we have to talk about what it eats, the data.
The data,
Yeah.
which has always been the biggest roadblock, just the inherent messiness of it all, scattered across thousands of different systems. The fragmentation. It's the true enemy of clinical context because you can't see the full story over time.
Now wait, isn't retrieval augmented generation RAG supposed to fix this? Why does standard RAG, which works fine for, enterprise documents, just completely fall apart here?
Because of context integrity. Standard RAG takes a document and just chops it up into arbitrary chunks of, say, 500 characters. In a normal document, who cares?
But in a medical record...
It's a disaster. Imagine a doctor's note. The first chunk might say, patient reported new onset tachycardia.
Okay, a rapid heart rate.
But the very next sentence, which standard RAG might just slice off into a separate chunk, is the critical part. Decision made to discontinue use of medication X.
Ah. If the AI only retrieves that first chunk, it misses the cause.
You lose the relational logic completely, the why.
So the solution isn't just a better rag, it's treating the data itself differently. And this is where the FHIR standard comes in.
Yes, FHIR Fast Healthcare Interoperability Resources. It provides the semantic blueprint we need. Instead of your medical record being one giant, messy PDF, FHIR treats it like a stack of standardized Lego blocks.
Lego blocks. I like that.
One block is patient, another is observation, another is a specific medication request. The AI can recognize the type of data, not just the raw text.
But getting thousands of different hospitals, some on ancient software, to speak this one FHIR language, that sounds, frankly, impossible for one company.
Right.
Which must be where the middleware partnership comes in.
It's absolutely essential. This is why the partnership with b.well Connected Health is so crucial. They are the interoperability backend.
And the scale is just immense.
I mean, think about it. b.well is ingesting data from over 2.2 million providers and 320 health plans. They map all that chaos into a single, unified FHIR R4 infrastructure. They're the ones bridging the gap.
So, okay, the data is now structured in FHIR, but even structured data can be incredibly wordy. I mean, raw medical records are full of what the sources call administrative noise.
Billing codes, insurance headers.
Yeah. Stuff with zero clinical value.
Right, and this is why they built the data refinery. Because in this field, token efficiency isn't just about saving money on compute.
It's a performance issue.
It's a huge performance issue.
Yeah.
If you force the GPT-5 thinking engine to sift through all that administrative fluff, you're just diluting its reasoning power.
So what's the goal of this refinery?
The goal is ambitious. A 10x reduction in token count from the raw input to the final, clean, AI-ready data that actually hits the model.
A 10x reduction. That's
Yes.
huge. It means they can either run it at a tenth of the cost or, and this is probably the bigger point, they can fit 10 times more of your actual history into the context window for deeper reasoning.
Exactly. You're turning a scattered, expensive record into a dense clinical signal. And the 13-step process to get there is intense, but we can kind of group it into 4 main stages.
Okay, what's stage 1?
Acquisition. Just pulling all that data from thousands of live FHIR APIs and health exchanges. Once it's in, you hit stage 2, governance and denoising.
This is where that 10x savings comes from.
This is it. Stripping out all the insurance junk, the administrative codes, all the redundant text, it's just noise.
Then comes the translation phase.
Standardization, right. Different hospitals use different internal codes for the same thing. This stage maps everything into the canonical FHIR R4 resources and, critically, translates all those local codes into universal standards.
So LOINC for labs, SNOMED for conditions.
Exactly. So the model knows that code 7187 from a lab in Texas means the exact same thing as the same code from a lab in California.
And the final stage.
Delivery and summarization. This is where they use clinical summarization on the fly. So instead of feeding the model 50 separate entries of normal sinus rhythm from the last 5 years,
The refinery just consolidates it into one single longitudinal summary statement.
a hyper-efficient delivery system for the data.
Okay, so we have this clean, standardized, hyper-efficient FHIR data. Let's talk about how the system retrieves it. This seems to be where FHIR RAG really specialized by just abandoning arbitrary chunking completely.
They move to what they call resource-type chunking. And this is the core innovation for keeping context. Instead of slicing text, the index treats a whole clinical unit like a single medication request as one indivisible object.
So the drug name, the dose, the prescriber, the start date, it all stays together.
Always, it preserves that clinical relationship.
But medical records are all about relationships. A diagnosis leads to a prescription, which leads to a lab test. Standard vector search just looks for semantic similarity, right? Heart and cardio? It would miss the A caused B logic.
And that relational logic is exactly why they use a vector graph hybrid index. The vector part handles the semantic similarity, linking hypertension to high blood pressure. But the graph overlay is the real game changer.
Okay, explain the graph overlay. How does it physically map these connections?
Imagine every single FHIR resource, each lab result, each medication, as a node in this giant network. The graph overlay then draws edges or relationships between those nodes.
So it's literally connecting the dots.
Literally. It adds an edge connecting a condition node for, say, type 2 diabetes, directly to the medication statement node for the drug used to treat it. And another edge from that drug to the observation nodes, your blood glucose levels, that monitor how well it's working.
Wow. So if I ask a really complex question, like, how has my heart medication affected my labs over the last 5 years? The AI isn't just searching for keywords.
No, it's using the graph to traverse the clinical connections of your actual health journey. It follows the edges.
And the retrieval for a question like that is a two-stage process.
Right, to maximize accuracy and context. Stage 1 is recursive stretch. The model first generates a targeted API query to the FHIR data to pull the exact structured points.
The numbers, the dates, the hard facts.
Hard facts. To ensure the critical metrics are 100% correct. Then Stage 2 handles the nuance.
The why.
The why. Stage 2 is semantic search, and it runs across the unstructured, free-text clinical notes. It pulls the doctor's narratives, the qualitative stuff. Then the GPT-5 thinking engine synthesizes both to give you a complete, grounded answer.
All of this tech, the specialized RAG, the 13-step refinery, it's all for nothing if you can't prove it's safe. The sources say that old benchmarks, like USMLE exams, they just failed.
They failed because they only tested factual knowledge. They didn't test for safe clinical dialogue.
Things like empathy or knowing when to ask more questions.
Or knowing when to escalate, exactly. The solution is HealthBench, and that is a new alignment target for this whole ecosystem.
The scale of HealthBench is pretty remarkable. It was developed with 262 physicians from 60 countries.
And it's made up of 5,000 realistic, complex health conversations, not just multiple choice questions.
And the granularity of the grading is what makes it so rigorous. They don't just score right or wrong.
No, they use physician-written rubrics with, get this, 48,562 unique criteria. They're assessing behavioral dimensions like context seeking. Did the model ask for more detail or emergency referrals? Did it pivot correctly when it detected risk?
Now, to scale this, they had to use a model-based grader, GPT 4.1. But doesn't using a model to grade its own successor create a bit of an echo chamber? How do we know it's a real measure of safety?
That is the critical question, and they anticipated it. They validated the grader externally. The model-based grader got a macro F1 score of 0.71 against a panel of human physicians.
And what does that mean in real terms?
It means its level of agreement is statistically about the same as the agreement rate between any two human doctors looking at the same case. So it validates GPT 4.1 as a scalable proxy for expert human review.
That is robust, and they built in a roadmap for the future. HealthBench hard.
I love this part. It's pure transparency. It's a subset of 1,000 extreme edge case scenarios, and right now, no model scores above 32% on it.
So the benchmark is unsaturated.
Exactly. To get better scores, they can't just tune to the existing answers. They have to fundamentally advance the reasoning of GPT-6. It forces real innovation.
Which brings us to the elephant in the room, privacy and compliance. The foundational pillar here has to be that no training policy.
That's the rule. Conversations in health are not used to train our foundation models. But a policy is only as good as the tech that enforces it, which is the isolation architecture.
So how does this compartmentalization work in practice? We need a better analogy than just encryption.
Think of your patient data like a highly classified book in a secure library. Your health chats are compartmentalized, totally isolated from general ChatGPT. When you start a session, your data is mounted for that conversation only.
It's like checking the book out into a locked, soundproof room.
Perfect analogy. And the second the session ends,
The book goes back.
the book goes back, the session memory is wiped clean, and no record remains in the model's transient memory. The permanent data lives in an encrypted, HITRUST certified silo. It makes data leakage technically impossible.
And because the AI avoids giving a diagnosis or treatment plan, OpenAI is very careful to position this with the navigator persona.
It's a smart and necessary regulatory strategy. By defining the model's job as support, navigation, and education, they avoid it being classified as a software, as a medical device, or SAMMD.
Right, they're sticking to the general wellness guidance. The goal is to help you prepare for a better conversation with your human doctor.
Not to replace them. And this deep integration with clinical records also creates a big constraint on the rollout.
A geographic one.
A huge one. Because of the complexity of connecting to all those EMRs through b.well, the medical record integration is currently US only. And the regulatory environment elsewhere is just prohibitive.
So no rollout in the EEA, UK, Switzerland.
Not for this integrated version. The GDPR and the EU AI Act classify this as high risk, and that just halts deployment for now.
So this whole deep dive really shows that ChatGPT Health isn't just an update. It's a massive architectural pivot. The AI is no longer a general knowledge engine.
It's a highly specialized, grounded, safety-aligned AI health navigator.
And the architecture is defined by isolation, that intense 13-step refinement process.
And that ability to process complex relational logic using the vector graph hybrid index. They solved the data mess with FHIR so they could finally feed a thinking engine.
But this leaves us with a final provocative thought for you to consider.
Given all this incredible rigor, the GPT-5 thinking, the 13-step refinery, the health bench standard, the model still only scores 32% on the hardest cases in health bench hard.
And its purpose right now is strictly navigation and support.
So the question is, what fundamental leap in reasoning, not just knowledge retrieval, does the next generation of AI need to make before that regulatory definition shifts? When does the tech cross that final gap from being a general wellness tool to being a tool directly involved in medical decision-making? That's the real challenge facing GPT-6.